Welcome. In this video lecture, we'll continue with our discussion on determining the complementary function for a linear ordinary differential equations of higher order. That is, we will determine general solution for homogeneous ODE, linear ODE. Okay. So in our previous lecture or previous video, we have seen how to determine the complementary function for f of d into y is equal to 0. So in this process of determining the complementary function, first step is we will have to determine the auxiliary equation, that is f of m is equal to 0. For this we will be determining the roots, let us say m1, m2, so on, and depending on the nature of this root, that is whether they are real distinct, whether they are real repeated, whether they are complex or complex repeated. Depending on these four cases, we have different type of solution, different ways to write the solution. So in continuation to our video, we'll discuss one or two problems in this session. Okay. First, let us move on to first problem. We have a second order differential equation here. In this second order differential equation, it's not in the standard form. That is, it's not in terms of capital D. First, I will write this in the terms of capital D. That is 2 into D square minus 5 into D plus 3 whole into y is equal to 0. So this is a second order differential equation. Now to determine the roots for this differential equation, we have to write the auxiliary equation, that is given by 2m square minus 5m plus 3, and I have to equate this to 0. That is, I have replaced this capital D as m and equated to 0, but remember we are not considering y. Okay. Now this auxiliary equation, it's a quadratic equation, we have to determine the roots. To determine the roots for this quadratic equation, you know the process, so I'll directly write the roots here. M is equal to 3 by 2 is one of the root and the other root is 1. So 1 and 3 by 2 are roots. Now here both roots are real, that's the first case, and they are all distinct also. Now to write the solution, I have to use the first case, that is the complementary function yc, that is nothing but actually here general solution y, and that is equal to, first is c1, because it's real we'll get e power m1x. m1 is 3 by 2 and x plus c2 e power m2 x, m2 is 1, so e power x. So this is the general solution for given homogeneous differential equation. There is nothing to be in doubt. Let us move on to the next second problem. Here we'll see a problem which are having the case 2. That is, we have real repeated root. Now to save the time, just I will go for directly auxiliary equation without writing the in the standard form. Here the auxiliary equation will become m square minus 10m plus 25 is equal to 0. You can see that this is of the form a square minus 2ab plus b square. Here a is m, b is 5. So this is actually my m minus 5 whole square LHS, RHS is 0. So both roots are here 5 and 5. Since we have real repeated root, the complementary function or the general solution for this differential equation y is equal to C1 plus, because it's repeated, I'll get C2x into e power mx, that is 5x. This can be written again or in the other way, that is just e power 5x can be multiplied to both, that is c1 e power 5x plus c2 x e power 5x. Okay, here one of the function is e power 5x and the second function is x into e power 5x. This is second case arises when we have real and repeated root. Actually, fourth case is similar to this. Next, we'll go on to one more problem. That is d square y by dx square plus 4dy by dx plus 7y is equal to 0. And this, if I write the standard form, m square plus 4m plus 7 is equal to 0. Now the roots are, I use the formula here, that is m is equal to minus b is minus 4 plus or minus root of b square, that is 16 minus 4ac. A is 1, c is 7, so 7 into 4, 28 divided by 2a. A is 2. That will be minus 4 plus or minus root of 12. That will be plus or minus root of 12 divided by 2. That will be equal to, we can write this as 2 into root 3. 2 to get cancelled will remain with minus 2 plus or minus, I think I missed here, this will be minus 12. So that will be I into root 3. This is of the form something like alpha plus or minus I into beta. So we have a complex root here. Alpha is, in place of alpha I have minus 2 and in place of beta I have root 3. Here plus or minus does not matter for us. Both ways I can choose. So beta is just simply root 3. In this case, we'll write the general solution for homogeneous equation, that is nothing but the complementary function, that is equal to e power alpha x. E power alpha. Alpha is minus 2, so minus 2x into c1 into cos beta. Beta here is root 3. Root 3 into x plus c2 sine root 3 into x. So this is the complementary function when we have complex root. I am not going to discuss any problem in fourth case, but that will be combination of second and third case. So this series of lecture, we have seen how to determine complementary function for a given homogeneous